So today we're going to start chapter 10. We are actually starting with 10.2. The stuff in 10.1 is not as big of interest to us, and it doesn't hinge or cause problems for us to move past it. 10.2, we're going to be taking a look at some basic graphs. That's really what we're going to be looking at. You see these graphs used all the way down to early elementary school. Early childhood people in here, that kind of stuff. You'll see these used at an early, very early level, some of them, especially the first one we're going to do. So the first one that we're going to do is a pictograph. A pictograph uses a picture to represent tallies within categories. And so, like the kinds of things that I see my daughter come home with, and she's in second grade, and she came up with similar things last year, is that they counted jelly beans. And so when she, is actually making her graph that has jelly beans in it, she's drawing jelly beans on the graph. I mean, that's what she's doing. So we're going to do something that's not quite so, like warm and fuzzy as jelly beans, our example. But our example is actually about deaths. Sorry about that. I should really change the example, shouldn't I? I should. All right, example number 1. The Automobile Club of America considers holiday weekends to start Friday at 6 p.m. and last until Monday at 6 p.m. If 150 people died on such a weekend by 6 p.m. Saturday, 80 people from 6 p.m. Saturday to 6 p.m. Sunday, and 100 from 6 p.m. Sunday to 6 p.m. Monday, draw a pictograph for the data. So we're looking at these 3 different categories, and it's based on time frame. That's how they've set this particular problem up. But they're really kind of big numbers. This is 150. This one's 80. And where's my other one? 100 down here. So I don't want to draw like a stick figure to represent every single person that is represented here in the death counts, right? Like that would be a lot. I don't want to draw that many stick figures. So when we're looking at a problem like this, where the categories would just simply be too big to draw that many figures, what we want is whatever shape we decide to draw to only represent more than one. For example, on this one, it works really nicely to either let whatever shape we pick here in a minute to represent either 10 people or 20 people works pretty well. If you were doing 10 people, you'd have to draw 15, 8, and 10 objects. That's not too bad. If you still felt like, maybe 20 people would be better, I could draw fewer objects, that would work okay too. I'm going to do it with 20 people because there's something inherent inside of that I'd like to show you what happens. But if you did this with 10 people, it'd be okay. So what I'm going to do first is I'm going to use a heart to represent our people. And there's a specific reason I'm using the heart. And the reason is because when I use my heart to represent 20 people, it's easy to draw half a heart and it be recognized as half a heart. And the reason that that's useful in this particular discussion is because when I do my 150 people, that's going to be 7.5 hearts. So squares are not very great to use because if you do half of a square, it might end up looking like a rectangle, right? So there's objects that are not as friendly to use. And then there's objects that just as long as you're careful would be okay. You could use squares if you wanted to. You just divide it in half like along a diagonal instead of in half to make it look like a rectangle, stuff like that. So you could use something different, but hearts are pretty nice to use. So in a pictograph, we need to list our categories. You can list them sort of vertically or horizontally. I'm going to list mine and draw mine out like this. So these are my 3 categories. And we can label them kind of whatever you want. If you want to be real specific, you can write down 6 p.m. Friday to 6 p.m. Saturday. I'm just going to call that Saturday because that's mostly Saturday. And then Sunday, and then Monday for my counts. But again, you can adjust that if you feel like it would be better to list more. And what we want is we want to draw the number of hearts represented in that category. So for example, on the first one, the Saturday one, that was representing 150 people, right? So if we take our 150 people and we divide by 20, that's 7.5 hearts. There's a little bit of a carefulness we need to have when we're drawing our hearts. Now I get to cheat because I have a copy-paste feature on my screen. You have to be more careful because you don't have a copy-paste feature, at least most of you I think are just doing it on paper itself. You need to make sure your hearts are the same size. I mean, that's really what it is. And that they're lining up. For example, this heart, and then doing like a heart like this, start to look like they're a little bit different. And depending on how careful and how close you draw things together, it may be really easy to draw your hearts in such a way that it ends up looking like 4 hearts on the top looks the same length, if you will, as 3 hearts on the second line. So you do want to be a little bit careful in how you're drawing them. Draw them as close as you can to the same size and lined up as close as you possibly can. So here's my 1, 2, 3, 4, 5, 6. I'll have to extend my lines because I didn't draw them long enough. 7. And then I need half a heart. And I'm actually going to draw mine and just erase the half I don't want. Whoops. The half of my heart is easy to draw as split. Okay, so there's my 7.5 hearts for Saturday. How many hearts should I have for Sunday? Yeah, it's 100 people, so I need to have 5 hearts. Oh, wait, was the 100 people on the last one? Sorry, it was 80, wasn't it?
Yeah.
So 4 hearts. Cool. Okay, there's the 4 hearts, and they should be lined up directly underneath the first 4 hearts of the Saturday column, or the Saturday row. And the last one was the 5 hearts that you guys were seeing for the 100 people. And again, they should line up underneath as close as possible anyway to making them underneath the other columns. There's something that's really important when you're drawing graphs. One of the pieces is what we already did, namely that if you're scaling something, you need to write it. So we let a heart represent 20 people. If you wanted, you could have let a heart represent 10 people, right? So sometimes there's some flexibility in that, but you have to tell me whatever you did. So there needs to be a key. That's what it really is, it's a key. The other thing a graph will always have is a graph will always have a title, which just describes what it is that you're measuring. So on this one, and it doesn't matter where you write the title, at least as far as I'm concerned, because it depends on the resources that you're using. Sometimes you see titles written above graphs, sometimes you see titles written below graphs, sometimes they're written on the side of them. I don't care. It just needs to be on there. So I've got some space underneath, so I'm going to write mine here. These are deaths on a holiday weekend. Where my heart is equal to 20 people. So if you have the heart equal to 20 people inside of the title, you don't necessarily have to have it somewhere else on there. It needs to be there somewhere. Anyway, any questions on the pictographs? Kids measure pictographs, they'll draw images. Sometimes they shade images in. Sometimes that's the way that they do their pictographs instead of drawing them themselves, which helps with alignment, of course, and things like that. So you'll see that at young levels of age. Our next graph is actually kind of similar to a pictograph, but it starts to be a little more abstract. So this one's called either a dot or a line plot. And I'm not sure why it has 2 names, probably just because it originated in 2 different places and they merged the ideas together. It's usually how that happens. So I usually call it a dot plot because we use the word line for a line graph later on. I don't want to confuse it. But a dot plot or a line plot is a quick way to display data with fewer than 50 values. And the way that it works is that it's much like my pictograph, except that every object this time is going to be represented with a dot or an X. And X's are what you usually see represented. So we have our example. These are the mass in kilograms of each child in Mrs. Good's class. So just as a ballpark, these are weights that would probably be appropriate for upper elementary school, if you're not sure what those are in kilograms. So a kilogram is about 2.2 pounds. Okay, so if you double all those values, you have numbers that are somewhere in the 80 to 90-ish range, or thereabouts, maybe 100 pounds on the upper end of things. So you're looking at a little bit older kids. And we're going to make a dot plot for the data. So what we do is we create a number line. Our number line needs to go from the smallest to the largest data value. So what is my smallest data value here? 39. And what's my largest? 49. So it will be much easier on your dot plot or on your line below if you don't start with 39 and end with 49 and try to do the hash marks in between. We want to make sure our hash marks are spaced roughly equally apart, so it'll be a lot easier to make that from scratch instead of try to piece in the hash marks in between. So if we start with the 39 and we decide this far over is 40, we would want to make all of our intervals about that far over. 41, 42, 43, 44, 45, 46, it's not quite far enough, 6, 47, 48, and 49. Okay, so this should look, visually speaking, evenly spaced out. And then what we're going to do is we're going to go through our data set just one at a time, and we're going to make a mark on our chart. So for the first one, we have the number 40. So I'm going to make a little X above the number 40, just like that. The next one is a 42. So I'm going to do the same size X as much as I can anyway, and I'm going to put it at the same level, if you will, above the 42. So they need to look like they're lining up, so horizontally on this one instead of like the last one, my hearts were lining up vertically. So that's my 42. And we're just going to go down the list. So I have 49 and 41. So it's 49. And there's 41. Now on this one, I think if I remember right, and I can check on my paper, yeah, I do actually have someone in each one of these categories. If I didn't, it would be okay. So it's okay if when we're done with all of this, you don't have an X in every single column. That doesn't have to happen. Can't get this 41 placed right. That's better. 43 and 42. So on 43, I didn't have one yet. Now I do. On 42, I already have one, so now I stack it. 48 and 39. So there's those, 46 and 41. Um, 42 and 40. So 42 now has 3 stacked on top of each other. (49 and 45). (39 and 43). (47, 44). And the last two are 49 and 42. It's probably the best dot plot I've ever made right there. Looks really good. Very clean. If yours don't look quite that clean, it's okay. But they should look like you've made the really valid attempt at making them look like they're lining up at the same size and all of that. So what is this doing good for you? This one, as well as the last, the pictograph, is that they create something visual that at a glance you can immediately say what you're seeing, right? The majority, or the most common weight, if you will, of the kids in the class is 42 pounds. More kids are on the lower spectrum of this than the upper spectrum, right? If we were looking at the last one that we did, we didn't really do a whole lot with it, but Saturday is worse than Sunday and Monday. I don't have to look at the numbers to make that decision. I can see it visually, right? So those are the things that we're able to do with these two types of graphs, is visually be able to see something just really quickly. I do need a title. So I'm always going to need a title. Here I don't need to write down that the X represents one person. That's always how they work on a dot plot. And you'll notice too that part of the reason for that is because it says that it tallies up fewer than 50 values. So we're not going to be doing anything that has more than 50 little X's. Okay, so it's not too cumbersome to draw with. But we do need a title for this, and so this is the mass. It does matter that we say in kilograms, because if these were pounds, we'd be looking at, the first grade classroom, not the fifth grade classroom or whatever it is that this is in. So it makes sense if we put the context in there as in kilograms of children in Mrs. Good's class. All right, any questions on those two? Okay, the next one is probably my favorite. I really like the next one. I think it just does so many wonderful things from the perspective of displaying or thinking about the data from a teaching perspective. So we're going to use some teaching data. It's called a stem and leaf plot. Have you seen stem and leaf plots before? Okay, we've got some nodding. That's good. They're akin to the dot plot, but they're drawn vertically. Instead of X's, we actually have the numbers that are on the left called stems, and the numbers on the right are called leaves. So these are typically two-digit numbers. They work best when they're two-digit numbers. And they're trying to display the tens digit on the left-hand side as the stem, and the ones digit on the right-hand side as the leaf. So here are some example data, and this actually was from one of my very early classes that I taught here at OBU from a specific exam. And these were the first exam scores. And we're going to create a stem and leaf plot. So the first one that we create, we're not going to try and worry too much about organization or size structure. When we create our refined or finished product, we will. And I'll show you why we want to create them twice. So the first thing is we're going to have a vertical bar. And we're going to put all the tens digits on the left, all the ones digits on the right. So taking a look at the numbers, I need to know my smallest value and my largest value. So what's the smallest you see? Which one? 43. Yep, 43. And my largest? 94. So my stems need to include everything from 40 to 90. So I have to have a 4, 5, 6, 7, 8, and 9. And I would include all of them even if I didn't have, say, any C's, right? There were no 70-somethings. There'd still be a 7 there holding its place. Otherwise, we collapse it and it starts to look sort of just misleading is what it really looks like when we collapse something like that. So we're going to include them all. And all we're going to do is like we did in the last one, we're going to go down the list one at a time and we're going to put them in the right places. So when I see 87 and 76, I put the 87's 7 in the 8 row, and 76, I put the 6 in the 70 in the 70s row. And I'm going to fill in all my data just like that, okay? Just put everything in its correct row. So I have 94 and 58. No worries about lining things up or anything, just putting them on there. 82 and 43. 89 and 53. 67 and 80. 90 and 94. 74 and 77. 87 and 74. 89 and 90. So this is the haphazard, just get them in the categories, right? So this is sort of like what you would do if you were sitting down with papers themselves and stacking up all my A's, all my B's, all my C's, right? That's what you're doing with the scores here. And then the second step is to actually put them really in order. So I don't want it to say 5 on the 5s row, to say 8 and then 3. I want it to go smallest to biggest, okay? So you're going to draw them and you're going to actually put them in order now. You still have the same 4, 5, 6, 7, 8, 9. But this time, as we actually put them on there, I don't know why it's so much smaller. Maybe I'll just try and make it a little bit bigger. This time, as we actually put it on there, we want to make sure that things are lining up. So, for example, when I do the 43 here, the 53 should have the 3s right on top of each other, and then there's the 8. Then I have the 67 should be right under the 3s. And in the 70s column, I have 2 4s, a 6, and a 7. So I should have a 4, 4, 6, 7, and they need to line up as we go. My 8s is 0 and then 2. And then 2 7s. And then 8 and 9 all lined up. And the last one is 2 0s and 2 4s. Oh, 2 9s. So sorry. Did I make a mistake when I did that, or did I make a mistake on my paper? I think I made a mistake on my paper. Okay, cool. Let's fix it. You said 2 9s, right? Thank you. Okay. So as I have this then, I can see lots of things, right? I can see that more students made Bs than any other grade. I can see that, yes, there was a few failing grades, but there's not a lot. I mean, we're definitely top heavy on the grades count, right? C's, A's, and B's are pretty good with this particular group. I can see the lowest value and the highest value at a glance. I know the lowest number. I know the highest number without having to search for them in a data listing. So there's a lot of really good things about a stem and leaf plot. I need a couple of things. Much like on the first one with my pictograph, I need some kind of a key that says what this is. Because we know, because we put them in there, what the numbers on the left of the stem, the stem pieces, and what the numbers on the right, the leaf pieces, represent. But that doesn't mean it's automatically obvious to anybody looking at this. So we need some kind of a key. We also need a title, because we always have a title. So I can incorporate both things together if I'd like. These are grades on a first exam. Where, and you can pick whichever one you want. I'm just going to pick the 3 at the top. Where 4/3 is a score of 43. If you don't like that one and you want to use a different one, that's fine. That's my title. Does that make sense? So a stem and leaf plot's really handy. I've used stem and leaf plots for my own benefit as an instructor many times to get some sort of feel of how the class is doing at a glance. There's some other things that I've used at a glance that are really nice too. I'll mention when we get to them. Another thing that you can do with a stem and leaf plot is that you can actually compare two different sets of data. So maybe you want to compare, this class to the same class that happened a year ago. Or maybe you want to compare this class's exam 1 to this class's exam 2, right? Are they making any progress in how to take a test in my class? So we're going to do the second one, actually. And what we do when we're looking to do this or whatever is they're called back-to-back stem and leaf plots. So there are two stem and leaf plots that are combined into one to show this data in comparison. Instead of just having the leaves to the right like we did before, we will have both leaves to the right and leaves to the left. And the stems will be sandwiched in between. So what we need to do in order to do this is we need to be able to take this next data set right here, and we need to actually have the stem and leaf plot that's itself, like that stands on its own. Right, I have this stem and leaf plot. This was exam 1. This problem wants me to compare that one to this particular data set, which is the exam 2. But I don't have the stem and leaf plot created for this particular one yet. So that's actually what I'm going to do first. We're going to make the stem and leaf plot from this data set. So in order to make the stem and leaf plot from this data set, we're going to do just like we did before. First identifying the smallest and largest numbers. So what do you see as the smallest? 64. And as the largest? 90 what? 9. There it is. Yep, 99. So I don't actually have to have my stems quite as expansive as I did over here, right? I don't need to go from the 40s to the 90s. But I'm going to merge these two together, so I'm going to go ahead and write it from the 40s to the 90s in a minute anyway to try to combine these two into a single graph. So just as an awareness kind of thing, I am going to have to include that eventually. But for right now, we can include only the pieces that are dated lists if we wish, 6, 7, 8, and 9. We're going to go through the data and we're going to categorize it. So 93, 96, 98, 66, 67, 82, 92, 85, 6481, 8672, 9695, 9994, 9474. Okay, everybody good so far? Did I miss one?
Yeah, you put 2 4s.
Yes, I did. I don't know how I did that or why I would have done that, but you're right. The one before is a 5. Thank you. Okay, any other pieces I recorded wrong? Looks good. Okay. So we're going to create the stem and leaf plot for this set of data, and then I'm going to copy it onto another page to merge them together where I've got a little bit more space. You guys have more space at the bottom of your page than I do, but if, again, you don't have enough, just flip the page over, whatever, or back page, or to another sheet of paper and add it to it. So I need my stem and leaf plot to have the 6, 7, 8, and 9. And I want to put the numbers in order. So in the 6's row, I have 4, 6, 7. And then I've got 2, 4. And the 8's row, I have 1, 2, 5, 6. And the 9's row is the toughest one because it's really very heavy laden. I have 2, 3, 4. And then I have 2 5s, so 5, 5, 6, 6. And then I have 8 and 9. So not only can I do, like I mentioned before, where I'm identifying, hey, look, there was a ton of A's on this test, right? And we can do that. One of the other things that you can do is you can find, we'll give it the name, the median, later on, but it's the middle value. So if you wanted to figure out, like, what's the middle value where half the grades are below this and half the grades are above this, you can do this from a stem and leaf plot really well. You can simply mark them off as you go, right? You can count off one at a time this way. And you can work your way to the middle value. Or you can count from the numbers that you're given, of course, too. But because everything's nice and neatly in order, it makes it easy to do that. Now what I'm going to do is I'm going to take this stem and leaf plot, which is incomplete at best because I don't have a title. But I'm not really trying to do that. I'm trying to create this back-to-back stem and leaf plot. And I'm just going to go back a screen because I have some space there. This is my second test, so I want it to be on the right-hand side because it came second. So sort of chronologically drawn. The other thing that I want to do is I keep pasting it, but I wanted to have the space at the top that I can put in those rows for the 4s and the 5s. Because over here, I do have a 4 and a 5 in my stems column, and I need that here. So I'm going to extend this vertically to now include the 3 and the 4 that I needed from before. Sorry, the 4 and the 5 that I needed from before. And then my stem and leaf my stems get trapped in the middle of the leaves like this. And then what we're going to do is we're going to take this stem and leaf plot and we're going to expand it moving to the left. So the first number on here is 43, so the 43 will have a 3 right here. And then it has a 3 and an 8, and we're working from the inside out, so this is the 3 and this is the 8. So the numbers are kind of going backwards of what they were before. On the 6, I have just the number 7. On the 8 and the 7s, excuse me, I have 4, 4, 6, 7. On the 8s, I have 0, 2, 7, 7, and then is it 9, 9? Yeah, 9, 9. And then the last one is 0, 0, 4, 4. Like so. So again, you can compare this really nicely. You can see all the grades kind of shifted down in the table, which is a positive thing, right, for our perspective. All of our grades sort of got larger in general. You can see a huge number of grades. I mean, it almost looks like all those B's moved into the A range, right? Like it got just sort of smushed downward. You can definitely see at a glance without making an actual calculation that the second test's average grade was better. right? You can see that. I don't know what the average is, but it's higher for the second test than it was for the first test without calculating anything. So it's got a lot of really good visual perspective sort of things with it. We do, in fact, need a key and a title again. So these are our first and second exam scores. So first and second exam score comparison. I am comparing them here. That's the reason I'm doing it this way. And I'm going to use the top row, or I think I will use the middle row where I've got the 6, where 7-6-4. So I'm picking this up from right in here. Means a 67 on exam 1 and a 64 on exam 2. Okay, does that make sense in terms of a title and to give some sort of context to what we've recorded? All right, cool. All right, our next one is actually called a grouped frequency table. So a grouped frequency table puts things into categories. So we're going to do something that's very naturally put into categories. We're going to do something with grades, but it doesn't have to be something with grades. People put things in categories all the time. One of the really common things you see categorized right now, if you go and look at like the dashboards for the COVID reporting, is they want to categorize people by ages. And it's very interesting because their categories are not even always the same width. All of our categories are going to be the same width because that makes more sense for what we work with consistently. And I would argue that it doesn't make a whole lot of sense sometimes for what's been going on with COVID and how they've reported that data either. But the intervals are going to be the same width. So the ones we're going to work with are going to be a grade comparison. So we're going to be looking at categorizing them in groups of 10, right? All the A's, group of 10, right? All the B's, not a group of 10, but a group of size 10. 10 is the width. So we're going to take that same data that we had before from the second exam, and we're going to create, using the standard grading scale, we're going to make a grouped frequency table. So in a grouped frequency table, what you have is you have the categories listed on the left. So the far left is whatever those categories are. So if it was categories by age, like you're seeing COVID listing things right now. And age is something that people do a lot with data, especially health data. Or it might be categories based upon weights. It could be categories based upon something that's very identifiable, like married, not married, boy, girl. So it doesn't have to be numerical categories either, although most of ours will be numerical. So our data, the smallest number on our table, if you'll remember, was 64, I think, and the largest one was 99. So as I'm looking at my data, I need to talk about the 60s, the 70s, the 80s, and the 90s for it to make sense, because I'm looking at grades. So this would be 60 to 69. This would be 70 to 79, 80 to 89, and 90 to 99. And you'll notice all of those widths are the same. And they're actually widths here of 10 values, right? There's 10 values between 60 and 69. The difference between them is 9, I realize that, but there's actually 10 values represented there. And I need a header for my column that says what it is, and so these are grades. You always have a column that's a tally column, and the tally column is lovely because what it means that you can do is that as you go through your data set, which our tally column may need to be wider, I should probably wait on that. Actually, I think I will. We'll just leave off the column ending for now. You can go through and you can actually make just hash marks, right? Like you're tally marking things. So 93 and 96 means that I have 2 tallies in this column. 98 and 66, 98, 66. 67, 82, 67, 82, 92, 85, 92, 85, 64, 81, 64, 81, 86, 72, 86, 72, 96, 95. So here's 96, 95, 99, 95, and then 94, 74. And that's my tally column. And the last column is actually the frequency column, and the only difference between the frequency column and the tally column is that we write the numerical value that represents the number of tally marks. So on the first one we have the number 3, the second one is 2, the third one is 4, and the last one is 9. So why do we do a tally column and a frequency column? Well, there's actually a couple of reasons. Number one, the frequency column is very handy for simply looking at it and saying, well, how many A's are there? Well, I don't have to sort of count, even if it doesn't take me that much. The tally column, right? I can just see the number. It says 9. The tally column is really nice because it's a lot easier to make tally marks than to go through a data set, especially if the data set is large, and actually make sure you counted up everything that was a 90-something. You are bound to miss it if the data set is big enough. You just are. You're going to miss something along the way, okay? So this has a nice feature because it puts things into categories. The problem with putting things into categories in general is that you lose some of the specificity, right? So like, yeah, I know I got 9 A's, but are those A's like 92s or are those A's like 98s? I lost something a little bit when I did that, right? But I gained something too, right? I gained the idea that, remember when I made the mistake and I wrote down an 88 instead of an 89 or whatever it was, and you were like, wait a minute, right? Well, I don't have to be as careful, right? I lost a little bit of specificity, but I actually get the ability to be a little less specific in doing so. I still need a title. What do you think might be a good title for this one? This is not the moment of creativity. You can just tell me what it is. What is this data? Okay, so it's grades. Specifically, what kind of grades, though? Grades from what? On a test. Specifically, it talks about it being a second exam, right? At the very beginning of the description here. So we can actually, you could say grade ranges. You could also just say grades, which would be fine too. So these are grades or grade ranges potentially from a second exam. That's it. I don't need a key here, right? I mean, this isn't like my stem and leaf plot or my pictograph where I need to figure out what that shape is and what it means. I don't have any of that going on, so there's no key necessary. All right, let me stop there because I can't finish the histogram example in the number of minutes I have left anyway, so we'll just pick up next time with histogram and go from there. All right?